Welcome back. Today we're going to be talking about volumes of cylinders. Okay, so to find the volume of a cylinder, let's look at the general formula for the volume of any prism. So first of all, a prism is defined as a three-dimensional shape that has the same polygon that makes up both ends of the three-dimensional shape. So for instance, this is a pentagonal prism because the base of the prism are both pentagrams, so or pentagons rather. Sorry. So you have this pentagon here is this first base, and the base on the bottom, which is a little bit difficult to see, is also a pentagon right here. Okay, so that would be the bottom. So this is a polygon because, or this is a cylinder because the same polygon makes up the base, and the sides between the bases are all rectangles. Right, this is called a triangular prism because we have triangles as the base, so the bottom here would look like this, and you have rectangles between the polygon bases. Now, a cylinder, although a cylinder is not technically a prism because the sides are not rectangles like you see in the pentagonal prism and the triangular prism. Its side is actually a curved surface like this. And actually, if I cut it open, it ends up being a rectangle. The side ends up being a rectangle. So it's not technically a prism, but we can sort of think of it as a prism in a certain way in that the bases are both the same polygon. So the bases are made up of circles here. So you have a circle here and you have a circle as the base here. So they're identical polygons that make up the base. All right. In any prism, the general formula for the volume of the prism is the big B, or capitalized B, times H. Now, the B is capitalized for a reason, all right? So when you write the volume of a prism, to be precise, you absolutely need to capitalize the B and keep the H as a lowercase letter. The B is capitalized because it's a formula within itself, okay? So this ends up being a formula within a formula. The formula B is the area of the base of the prism. So for a cylinder specifically, we can take this general formula, and instead of putting this capital B in it, we can find the area of its base, which is a circle, right? The base is a circle, so the area of a circle is pi r squared. Okay, so instead of big B times H, which is the area of the base times the height, what we have is we have pi r squared times H, because we know that this B can be substituted in for the expression pi r squared, right? Here is the area of the circle, that's the base, times the height of the cylinder. Now let's just think about this for a second. Volume is actually a nice, easy formula for the most part for prisms, because what you're doing is you're taking the area of the base and you're multiplying it by height. And the way that I always remember is I just think of making little tiny circles all the way along this cylinder, so that how many circles do I make? I make the height of the cylinder. So essentially it's like, or another way of thinking about it is filling the cylinder up with water, and each layer of water is like a little flat circle. So I'm like stacking these circles up. And the height of the cylinder ends up being how many of these little flat circles I can stack up. That's an easy way for me to remember it. So the volume formula for a cylinder is pi r squared times H. And this is absolutely something that you should memorize, okay? And it's going to be helpful for you when you get to high school and you do geometry, and you need to know all of these formulas by heart. Okay, so let's take a cylinder in particular. So remember, this is a cylinder, and this particular cylinder is sort of laying, it's laying in such a way so that the circle, it looks like, it appears to be on a table or a horizontal surface. But this is the same as if I tilted this around, right? The cylinder doesn't lose its volume if I tilt it this way, or tilt it even diagonally, right? So what I do is I identify what the base is, which would be right here. Here are the two bases. There's the top or the side and another side, or one base and another base. And I look at the radius of this base, okay? And then I identify what we call the height. Now, we call it the height because it's typical that the orientation of this cylinder is such that let me tilt it back around. It's very typical that the orientation is so that the bases look like they're lying on horizontal surfaces. But again, it doesn't matter if it looks like it's tilted in any way. It doesn't lose its volume if you tilt it. But we call the distance between the two bases the height in this case. And again, it has nothing to do with the orientation of it because you can change the orientation. All right, so volume is equal to base area times height. So in our particular case, it's pi r squared times h. Okay, so whenever I find the volume of a cylinder, I always rewrite the formula. So I could always go volume is equal to pi r squared h. Now my next step is I substitute the values in for r and h. Remember, pi is a constant. It doesn't change. It happens to be an irrational number. So if I have a calculator and I press the pi key on my calculator, so your calculator, this is the pi key, and I press enter, my calculator is actually going to give me back that symbol itself, because what it's doing is it's storing it as an irrational number. Now that's not going to be super helpful to me when I start to do calculations, and I'll show you why that is in just a second, and I'll show you how to get around that. Okay, so for us the radius is 3 and the height is 10, so I want to say pi times 3 squared times 10. Notice the 3 is the base of the exponent here. It's not 3 times 10. So what's going to happen here with the calculation is this is pi times 9 times 10. So pi times 9 times 10, and if I multiplied those two together, I would get 90 times pi. Now 90 pi is just a number that has not been essentially multiplied. This is a rational number times an irrational number. And when I multiply a rational number times an irrational number, I end up getting an irrational number, right? Because think about the characteristics of an irrational number. The decimal goes on, and it doesn't repeat, and it doesn't terminate. So if I take a nice number like a rational number, and I multiply it by something that doesn't terminate, doesn't repeat, I'm going to get a number that doesn't terminate and doesn't repeat. Okay. So if you look at the calculator, now if I were to estimate this, by the way, it would just be like one estimate for pi is approximately about 3, right? It's approximately about 3.14, so it's about 3. So 90 times pi would be, about 90 times 3, which is, 27 with a 0 on it, 270. So this is approximately equal to 270 degrees, or it's 270 inches. And that's going to be in cubic inches because volume is in cubic inches. Okay, so we can even get a better estimate if we use a calculator to estimate the actual value of what 90 pi is. Now, the state test is going to ask you to report the volume of a cylinder in one of two ways. They can ask for you to give it to them in terms of pi, in which case you would say 90 pi inches cubed, okay? Or they're going to ask for it in terms of, or they're going to ask for it rounded to a certain value. They could ask for it rounded to the nearest tenth, for instance, to the nearest hundredth, to the nearest 1, in which case they actually want you to take 90 and multiply it by pi. So we're going to grab our calculator here, and we're going to let's put in the original equation that we have, or the original expression that we have, which is pi times 3 squared times 10. Okay, so that will be pi, and by the way, always use the pi key on your calculator. Don't put in 3.14. In 8th grade, at least on the test, you will get the question wrong if you put in 3.14 and not use pi. We are assuming that 8th graders are using calculators with a pi key on them, and that's part of what we are requiring students to understand in 8th grade, that there's a difference between pi and the number 3.14, that 3.14 is just an estimate of pi. So you absolutely need to use this key here while you're calculating this. Now something strange happens. Let me show it to you. Pi times 3 squared. Now there's two ways to get the squared key. You can either do this key right here, which gives you an exponent of 2, or you can do this little caret key, which puts it in puts the blinker up into the superscript, which is the exponent position. You can put a 2 here. Notice that you're still stuck up here, so you have to press the right arrow key in order to be able to multiply this by 10. Okay. Now, when you press enter, you'll notice that your calculator gives it to you in terms of pi, which is not super helpful if you're asked to actually calculate what this value is, or estimate the value of it other than 90 pi. So remember, 90 pi is the most exact form of this number because it's just, you have the irrational number as a symbol here, as opposed to having it multiplied out. Now, what some students will do is they'll just take 90 and multiply it by 3.14. But I do not want you to do that because it's very likely, let's look at what happens. This is 282.6. Okay. But remember, this is just an estimate, and whether or not this is a good estimate depends on what they ask you to round to. Okay. If they're asking you to round in the nearest hundredth, you would put 282.60. Now, it's very likely that you're going to get something different if you actually used more digits of pi in your calculation. So instead of doing this, what I want you to do, so if I arrowed up and I put 90 pi like this, okay? Now, the reason why it's giving it to you in 90 pi is because if you go into mode, by default, your calculator is set to something called math print, okay? Now, math print is something that makes things look nice on a calculator. So it makes the exponents go in a superscript position, for instance. That's one thing it does. And it gives you things in terms of pi as opposed to giving it to you as a decimal. So what I want you to do is I want you to go down to classic mode and press enter. All right, you know math print was already selected because it was it had been highlighted before, or it had been in the solid print before. Now classic is highlighted, so if I use my up arrow key, you can notice now that classic is highlighted. Let me go to quit, and if I press 90 pi here, and I press enter, you'll see it's 282.74. So you'll notice this is different than what we got before. We did 90 times 3.14. And in fact, if they asked you to round to the nearest hundredth, you would have just gotten that question wrong if you used 3.14 instead of using pi, or more digits of pi that your calculator is storing. So here our answer is 282.74 inches cubed. Okay, so this is a better 282.74 inches cubed. Oops, that's a 4 right there. And that's a better estimate of what this volume is other than 270. All right, now notice that I'm using equal symbols all the way up here, and then I have to switch the approximately equal to symbol here because at this point when I calculate 90 times pi, since pi is an irrational number, anything that I write down as a terminating decimal is going to be approximately equal to. Okay? Okay, so let's move on to another example here. What you'll notice about this example is that the cylinder is oriented so that the distance between the bases is on a horizontal plane, or it looks like it's on like if this were a tabletop, right? As opposed to what you saw before where that distance was located like a height, all right? Or another way of saying it is it looks like the bases are sitting on the table as opposed to here where it looks like the cylinder's been sort of knocked onto its side. Now remember, the volume doesn't change, right? The same amount of water that can be held in this cylinder can also be held in the same cylinder if it's oriented like this, right? So it doesn't really matter which way you orient the cylinder. And this distance here is still described as the height. So don't be confused by that. The height is just the measurement, the distance between the two bases. So our volume formula is pi r squared h. Always start by rewriting the formula. And then the next thing you want to do is you want to think about how to fill in the r and the h. Now notice they give you the diameter here. And this is something that they love to do. They love to make sure that you're paying attention by giving you something like the diameter instead of the radius. In the last example, they gave you the radius. Okay. In this example, the line goes across the entire base, indicating that 6.4 is actually the diameter. So to get the radius, you would divide by 2 to get 3.2 centimeters. Okay. And so our volume is equal to pi times 3.2. Notice I'm going to put that in parentheses, and then I'm going to square it. Okay. And my height is 13 centimeters. Okay, and so let me pull out the calculator. So I have pi times 3.2, and that's going to be squared, times 13. Okay, so I have 418.21 if I'm rounding to the nearest hundred. I have 418.2 if I'm rounding to the nearest tenth. Remember, if I'm rounding to the nearest tenth, I only have to look at this 0 right here. I only have to look at the place value right next to the tenth place in order to determine whether or not this number goes up by 1 or stays the same. All right. It's if I'm rounding to the nearest whole, it would be 418. If I'm rounding to the nearest 10, it would be 420. If I'm rounding to the nearest 100, it would be 400. Right. So depending on how they ask this to be rounded to, I'm going to round to the nearest 10 here. So I have 418.2, and this is going to be in, let me just make sure that's okay, 418.2, yes. And that's going to be in centimeters cubed. Okay, and that is the end of our lesson for today. Thanks.